Today we're doing the fourth set of notes on the matrix chapter. So just like multiplication for matrices has a special way to multiply, division is the same. So when you would look at this, normally you would say, oh, I would divide that matrix over. Well, I can't divide a 2 by 1 by a 2 by 2. So there's a certain way that we go about this. So whatever matrix is in front of your variable, you find the inverse of. So we need to find the inverse of this matrix right here. And to do that, again, we do 1 over a times d, so 5 times 2 is 10, minus the 3 times 3, which is 9. So the fraction out front is going to be 1 over 1, so that's not going to change anything when I multiply it in. And remember, I have to scramble the matrix up, so the 2 and 5 switch, and both of these 3's become negative. Now, when I multiply the fraction in of 1 by 1, nothing's going to change. So this is my inverse matrix. So now you take your inverse matrix and you multiply by the answers that it's set equal to. So I have a 2 by 2 times by 2 by 1, so your final answer is going to be a 2 by 1. And remember the whole row by column. So 2 times 1 is 2, times negative 3 times negative 3 will be plus 9. And then the second row column and the first column, negative 3 times 1 is negative 3, and 5 times negative 3 is negative 15. So now you add them together and you get 11 and a negative 18. So this is your answer to the problem. So let's try another one. Again, notice the matrix that's in front of your variable is this right here. So this is the one we find the inverse of. So I do 1 over 4 times 2 is 8, minus 3 times 2 is 6. So 1/2 is the fraction out front. We scramble the matrix, so the 2 and the 4 switch, and the 3 and the 2 become negative. And then the last thing we need to do, obviously, is multiply this 1/2 in. So the inverse becomes 1, negative 3/2, negative 1, and a 2. So I'm going to take this matrix and multiply by the negative 5, 2. So I have this 1, negative 3/2, negative 1, 2, and I multiply it by negative 5, 2. So again, the whole idea of row by column, row by column. So 1 times negative 5 is negative 5. Negative 3 over 2 times 2 is negative 3. Negative 1 times negative 5 is 5. 2 times 2 is 4. So our final answer for this matrix, or what x equals, which is what we were solving for, is negative 8, 9. Okay? So that's how we solve matrix equations when a matrix is being multiplied by x. So the next skill we're going to talk about is when you have a system of equations and how to put it into a matrix equation. So the first matrix consists of your coefficients, and coefficients are the values in front of your variables. So I have 4x's, 7y's, negative 5x, and 3y. The next matrix represents your variables. So my variables are x, y, and we set it equal to the constants. So 6 and 1 are your constant values. And that's it for right now. So this page is just practicing setting up a matrix equation. On the next page, we're actually going to solve these. So let's try one more. So my coefficients, I have 3, 5, and a negative 12. For the second line, notice there's no a, so there's 0 a's, 7 b's, and 2 c's. For the next line, I have 5 a's, I have no b's. Now this 3c is on the other side of the equal sign, so before I can write this value down, I'd have to move it over. And to move this 3c over, I'd have to subtract it. So your c value is actually a negative 3. Your variables are a, b, c, and the constants are 6, 8, and a 1. And that would be it. So this page again is just practicing setting it up. On the next page is where we're actually going to solve. So the next set of examples, we're going to kind of morph these two ideas that we did at the videos and the video so far together. So first thing we do is we set up our matrix. So we have 5, -4, 3, -2. And I take my variables of x and y, and I set it equal to 4, 3. So, like we did in the first part of the video, you can't just simply divide by this 2 by 2 matrix. We have to find the inverse of it. So that whole concept is going to come back. So I need to find the inverse of this matrix right here. So I have 1 over -10 minus 3 times -4 would be -12. So my fraction will be 1 over 2. And I need to scramble this matrix up. So -2 and 5 switch. The 4 is positive, the 3 is negative. And then the last thing I need to do is distribute the 1/2 in. So this inverse matrix becomes -1, 2, -3/2, and 5/2. And now, just like we did earlier today, I need to multiply it with the constants of 4 and 3. So the first spot, we do the whole row by column. So -1 times 4 is -4, 2 times 3 is 6. And the bottom, -3/2 times 4, so I get -12 over 2, which is -6. Then 5 times 3 is 15, 15 over 2. I'm going to write that as a decimal because it'll be easier for adding. So when I put this together, I get 2 and a 1.5. So to interpret this in the context of the problem, x equals 2 and y equals 1.5. So you can write your final answer like this, or you could write your answer as a coordinate pair. I would accept either. Okay, so let's try one more. So again, we start with setting up our matrix equation. So I have 9, 2, 3, 1 times xy. And then we set it equal to 3, -6. So we're going to start by finding the inverse of the matrix in front of the variables. So I have 1 over 9 times 1 is 9, minus 3 times 2 is 6. So I get 1/3 for my fraction. And I switch my 1 and 9, the -2 and the -3. And I need to distribute the 1/3 in. So I get 1/3, -2/3, -1, and 3. And now I need to multiply this with 3 and a -6. So again, row by column. So 1/3 times 3 is 1. -2/3 times -6. So I have -2 times -6 is 12. 12 over 3 is 4. And then -1 times 3 is -3. 3 times -6 is -18. So I get 5 and a -21. So again, to interpret this in the context of the problem, x is 5 and y is -21. So that's all for today.